Okay, guys, good morning. Happy Friday. We had no homework from Tuesday. I just asked you to take down some notes. So the notes we took down, it was all about the reactivity of metals. So how metals react with water and how metals react with oxygen. So today we're going to look at atoms in reactions. Okay. So the first part here we've actually already discussed, because we talked about it. I think it was in the right to reaction chapter. We talked about this. So we were talking about this law of conservation of mass. So essentially, the mass of the reactants is always the same as the mass of the products. It's just that they get rearranged, they get moved around, but the mass is the same overall. So you end up with the same amount of atoms. Like this first example here is magnesium and chlorine. You end up with the same amount of atoms of magnesium that you started with and the same amount of atoms of chlorine. It's just that they're arranged differently, okay? So this is not new. The law of conservation of mass tells us the mass of the reactants in a chemical reaction always equals the mass of the products. This is because atoms are not destroyed, they are just rearranged. Okay, so on the left hand side here, we have one magnesium atom, and here it is here on the right. It's just on the right, it has now become involved in a bond with the two chlorine atoms. Okay, and same thing, we have two chlorine atoms on the left, and we still have two chlorine atoms on the right. Okay, look at a slightly more complicated one. So this is a reaction between hydrochloric acid, which is an acid, and sodium hydroxide, which is a base. So it's an acid-base reaction, and when you mix an acid and a base, you get a salt and water. Okay, the salt here is sodium chloride, and then water is just water. Okay, but again, if you try and follow the atoms, so over here we have the reactants, the acid and the base, and over here we have the products. Yeah, so on the left we have a chlorine. Here it is here. It was in a bond with a hydrogen to give you the hydrochloric acid. We still have the chlorine over here on the right, but now it's in a bond with sodium. Sodium is here in a bond with the oxygen and the hydrogen. So that's your sodium hydroxide. And we still have the sodium over here on the right. It's just now it's in a different bond with the chlorine. Okay, on the left we had one oxygen atom. There it is there. And we still have one oxygen atom. On the left, it was making up part of the sodium hydroxide. On the right, it's making up part of the water. And then we have two hydrogens on the left involved in both of the compounds actually. So it's part of the hydrochloric acid and it's also part of the sodium hydroxide. And then on the right, we still have two making up the water. Okay, so again, overall, the mass of the reactants and the mass of the products are the same. It's just they're completely rearranged. Okay, so we're going to look at those atoms up here. As I said as I was talking through it, that they were in bonds. Okay, so I said here the hydrogen is bonded to the chlorine, and then over here it's now bonded to the sodium. Here the hydrogen was in a bond with the oxygen and the sodium, but over here we actually have two hydrogens in a bond with oxygen, okay? So we know that these bonds are formed. We know that water is H2O. We know that carbon dioxide is CO2. So all of those things are compounds, okay? So we're aware that elements combine with each other to form compounds, okay? Compounds that we know are H2O, CO2, and there's a couple up there, HCl, NaOH. Okay, lots of different ones where you have elements like sodium and hydrogen and chlorine and oxygen combining to make compounds. So to form those compounds, they have to bond. Okay? The reason they bond, I suppose that's quite important. They bond to make themselves more stable, to have lower energy. Okay, so normally the compounds would have, the bond in the compounds would have a lower energy and be more stable than the atoms alone. And we'll talk about that now in a second. So, atoms form bonds using the electrons in their outer shell only. So I'm pretty sure we did a little bit of work on bonding. What's that? Sorry, I'm gonna have to check this. I just want to see. I don't want to mix you up with the third years and be assuming you know something that you don't know. That was solubility. We did. Okay, we did. So back here when we did chapter 10, which would have been at the end of first year. So this would have been lockdown last year. We did work on atoms and elements, subatomic particles. So we talked about protons, neutrons, and electrons. We would have learned how to draw the, when you put the 2 atoms in the first ring and then 8 in the next, and so on and so forth, and how to read the periodic table. Okay, so you do have the information I had hoped you had, so that's fine. So it's chapter 10 you might need to look back on. Okay, so atoms form bonds using the electrons in their outer shells only. We'll have a look at that now in a second. And the outer electrons, so they can either be shared or transferred. Okay, actually I'm going to do a bit of a colour on this, sorry, I'm going to take them out for now. Okay, so they can be shared or they can be transferred. Okay, if they're shared, so green to green, it's a covalent bond. If they're transferred, it's an ionic bond. Okay, so in an ionic bond, an atom loses or gains electrons, but they're actually passed from one element to another. In a covalent bond, so the word co, let's not change the colour there. Co, so if you cohabit with someone, you live with them. So co is to share. Okay, the whole reason for bonding is that atoms either lose, gain, or share electrons so that they can gain a full outer shell. Okay, that's what they're trying to do. They're trying to gain a full outer shell, because if they have a full outer shell, then they're stable. Like we were talking about reactions of the day and about how readily those group 1 elements react, like sodium and potassium. And the reason they react so readily is because they only have 1 electron in their outer shell and they want rid of that electron. Okay, so what I'm going to do here before I go into bonding is I'm going to make sure you know or remember how to do these. Where are they? Here. They're called Bohr models of the atom. So I'm going to just erase this. Okay, and I'm going to snip this into your notes. Okay. I don't know what I just did there. Okay, there we go. Okay, so if you remember, Group 1? Yeah. So these are all your group 1 elements. Yeah? And now I'm not going to go through all of these. I'm going to let you do some of them. These are your group 1 elements. What that means is they have 1 electron in their outer shell. Okay, now an outer shell shell should have 8 electrons. So that means to fill up the outer shell for group 1 elements, they either need to get 7 from somewhere else or they need to lose 1. Okay, so it's much easier to lose 1 than it is to gain 7. So they lose that 1 quite easily, and that's what makes them so reactive. They're massively reactive because all they want to do is give away that 1 electron. They're like, just please take it away, and then I can be stable and I can be happy. That 1 extra electron makes them unstable, makes them reactive. It's why they have to be stored under oil. Whereas once they lose that electron, then they become very stable. Okay, so let's have a look. I don't want to do a crazy one, right? But we'll do potassium. Okay, so potassium's numbers are 19 and is that 39? You can just round these, just make sure you round them properly. So 19 and 39. Okay, so this up here is the number of electrons. It's also the number of protons. Okay, the number of electrons and the number of protons in an atom need to match because electrons are negative and protons are positive, and you need overall for it to be balanced. Okay, so there are 19 electrons and there are 19 protons. Okay, so let's try and draw it. Okay, so I have potassium, and here's my first, oh, what happened there? Oh, there you go. There's my first ring, okay? In the first ring, you put in 2 electrons, okay? The first ring will only hold 2. So that's 2 down, 17 to go. Okay, second one. This one will take 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in total. Okay, we're trying to get to 19, so we can go again. Yeah? So what am I up to? 10. Okay, so this is 11 and 12, 13 and 14, 15, 16, 17, 18. And now that shell is full. Yeah? But I have 1 electron left. So I'm going to need to go to another shell. I don't mean these to be going off to the left. They just are. So where will I put it? I'll put it over here. Oh, sorry. Okay. There you go. No, it's gone all slow. So that's how I build my, it's called a Bohr model. Okay, that's how I build my Bohr model. And you can see that when I build my Bohr model and I do it correctly, that I end up with 1 electron in the outer shell of potassium, and potassium is a group 1 element, so I would expect to have 1 electron in the outer shell. Okay, your group 2 elements, if your group 1 elements have 1 electron in the outer shell, then your group 2 elements should have 2 electrons in the outer shell. Okay, so that's our group 2. So you would expect these to have 2 electrons in the outer shell. So when you draw those ones, magnesium, for example, magnesium has 12 electrons. So you can see the 12 there. Yeah, 12. So that would be 2 in the first, 8 in the second, that brings you to 10, and then 2 left for the next ring. 2 in the outer shell, okay? We skip the middle elements there, the transition elements, and group 3 then is here. And group 3 elements have 3 electrons in the outer shell, and then so on. Group 4 is here. That's group 4, and group 4 have 4 electrons in their outer shell. And this one here is group 5. Okay, and so on. Okay, I'll do one more. This is group, this here is group 6. So that's your group 6. I'm not going to write it, but group 6, 6 electrons in the outer shell. Here's group 7. They have 7 electrons in their outer shell. So group 7 are really good friends with group 1 because group 1 want to give an electron away and group 7 only need 1 electron. Do you know? So they pair up quite nicely. So this is group 7. This one here was 6. And then the last one there, go with this one. So group 8 here have 8 electrons in their outer shell. So that means they already contain a full outer shell, which means they are completely stable with a full outer shell. So they don't get involved in reactions at all because they're happy. They don't need to get involved in reactions. Okay? So I'm going to pick a couple of elements and I'm going to ask you to do the Bohr model for those elements. Okay, because what we're going to do next when we do bonding is that we're going to combine them. So we're going to do the Bohr model, say, for a group 1 element like sodium, and we're going to do the Bohr model for a group 7 element like chlorine, and we're going to smush them together to create a compound, a bonded compound. So if you can't draw the original Bohr models. You won't be able to draw the bonded Bohr models. Okay? So I'm going to pick a few. So let's see. Take that off, make that 18, and make it black. So draw the Bohr models for the following elements. Okay, so the first one I would like you to do sorry, I need to have a look. Yeah, we'll do calcium. Second one we'll do let's go with aluminium. Aluminium, yep. Third one, we're going to go with silicon, and then we'll do oxygen. Okay, so silicon, and then oxygen. Okay, so I'm asking you to draw 4 of them. You need to find them first. So obviously in the periodic table, they're there just as their symbols. So you will need to figure out what the symbols are. Google will be your friend. Find them. Find out what group they're in so that you know what to expect. So, you know, if you're in group 2 and you're expecting 2 electrons in the outer shell and you don't get 2 electrons in the outer shell, then you know you've put the dots in the wrong place. Okay? Remember that we're working on the number of electrons is the smaller number. Okay, so that's the number you're working on. So the other number, the number that needs to be rounded, you won't need to deal with it anyway. Okay, so if we were doing magnesium, we would be using 12. If we were doing boron, we'd be using, what the hell is that number? 5. If we were doing boron. If we were doing carbon, we'd be using 6. Nitrogen, we'd be using 7. Okay? That's how many electrons you need to fit in. Remember, 2 in the first shell and then 8 in every shell after that until you run out of electrons. All right? So that is your homework and it is due for Tuesday. All right, guys? Have a great weekend.